This is 4.2a, the first video in elementary algebra on the elimination method. And in 4.1, we started getting into systems of equations, which if you remember right, it was, at least in this particular section, we dealt with two equations, and each of the equations had an x and a y. And we would graph each of the equations, and where those equations, or the lines of those equations crossed, that was the point that we had in common. Okay, that each line had in common with one another. Okay, so this red line and this blue line have this point right here in common, which means that is an answer, or the answer, to this particular system is where they cross. That's where the x and the y are the same numbers. And that's what we're looking for here. Okay, one of the things that I said quite a while ago, and I don't even remember what lesson it was in off the top of my head, but I said whenever you have one equation, the only way you can solve that equation is if the number of variables is 1. Now let's go all the way across the board with this. If you have, well, let's just say it this way. The number of variables you have in an equation determine how many equations you need in order to solve the problem. So, for example, if I have the problem 3x plus 4 equals 10, there is one variable and one equation, therefore I can solve for x. If I have 3x plus 4y equals 10, I cannot solve that equation because I have two variables in the one equation. But if I do this and call that a system with two variables and two equations, then there's a method that I can use in order to solve that. If I were to have, and heaven forbid we do this yet, but I'm just going to write it down there. I have an equation with three variables in it. That means the only way to solve for x, for y, and for z is to have three different equations that have x, y, and z. So I can have that equation and 2/3 x minus 4y plus 16z equals 72. Okay, I can solve for x, y, and z because I have 1, 2, 3 equations. Three variables, three equations. So that's a good rule to remember, that if you don't have enough equations, or the number of equations as you do variables, you can't solve it. And that's what we're doing systems of equations for, is because sometimes you need to find out what x is and what y is, and you can make that determination if you have two equations. And so that's what we're going to do in this section right now. So, for example, the first example is x. If I get my pen working here, x plus y equals 4. And the other equation is x minus y equals 2. There's my system. Now in the last section we just graphed. 2 plus 2 is 4, so 2 is my x and 2 is my y. And then I looked at this one, or, well, and let's put another one on here. And then I did, let's say 3 plus 1 equals 4. So 3 plus 1. So there's my x and my y. There's my graph for this equation right there. Now my other equation says that x minus y equals 2. So 5 minus 3 equals 2. So if I were to graph that, 1, 2, 3, 4, 5, and my y is 3, so I've got a number like right here, 5, 3. And I could also say negative 4 minus negative 6. So negative 4 minus a negative 6 is the same as negative 4 plus 6, which equals 2 here. So I'm going to graph that in red. Negative 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that other point's here. And what we did in the last section is where these two lines crossed was the answer to our problem. Okay, one of the things that you noticed was that when you graph, you don't get things that are real accurate. You know, it's kind of a guess where they cross sometimes. So we're going to do one that is not only more accurate, it is exactly the right answer. And we're going to do it without graphing. We're going to actually use algebra in order to solve this. All right, so the elimination method, what that means is that we draw a line here, we add the x's, we add the y's, y plus negative y is 0, so those go away, and then we add what's over here. And guess what happened? We're down to how many equations? We have one equation, and how many variables do we have? We have one variable, so it's solvable. So notice what we did. We went from 2 equations, 2 variables, simplified it to 1 equation, 1 variable, and now we can solve it. And that will always be the case on how you do these. So we're going to divide by 2, x equals 3. Okay, but one of the things you'll notice is we're not just solving for x, we're also looking for y. It has an x and a y in here, so we have to find both. So what you do is you take either one of these equations, does not matter which one, let's just take the top one. And we're going to put a 4 in, or a 3 in for the x, because that's what we found x to be. And that means that when x is 3, y is going to be what? 3 plus what equals 4? Y is going to be 1. So what does that mean? Okay, what that means is if you were to have graphed both of these equations, where the two lines cross would be at this point, 3, 1, over 3, up 1. It also means that 3 and 1 make both this equation and this equation a true statement. So if I put 3 plus 1 here, I get 4. If I put 3 minus 1 here, I get 2. Makes both of these true. So that's what we're finding out here. What two numbers are going to make each of these equations true, and when we graph those two equations, I'm just going to throw some things out here. When I graph those two equations, I'm going to get a point where they cross at 3, 1. Okay, so that's what we just found out. Okay, so let's try another one of these. This is, in fact, number 8 in the problem set. And I want to do some practice before we get into some other options here. Alright, so what we do is we draw a line under there and put a plus sign. And notice what happens when we add these two together, they go away, right? Positive 2x minus 2x. So if we have 2x's and we take 2x's away, we get 0. Negative y plus negative y is negative 2y, and that equals negative 2 plus 2 is 0. Let's divide by negative 2, divide by negative 2, and it doesn't matter what number is on the bottom because the 0 is on the top, y is 0. Alright, now we need to find the x value. So we're going to take either one of these equations, whether it's this one or this one. Let's take the bottom one this time. And we're going to put a 0 in the y's place, which gives me this. Divide by negative 2, divide by negative 2. Those cancel. X equals 2 over 2, which is 1, and we have one negative there, so we have a negative 1. So when y is 0, x is negative 1. So there again is the place where the two equations cross. Okay, that's what we are looking for. And again, I just kind of drew that graph just to show you that's what we're looking for, is where they cross. They actually, I guess they don't cross where I have the blue line. I guess I should do it because they cross at negative 1, 0, don't they? So they really cross there. So this line and this line, that's what we are looking for. Okay? Now, as you're doing these, one of the things that you'll find out, and that's what we're going to go into right now, and the book kind of jumped into that right away. Look at our original equation here, this one right here. Now, when we added these two, the x's canceled and became 0, which left us with just one variable, right? In the first one we did, the y's canceled out. We only had one variable, but sometimes neither one of these will cancel out, and that's what we're going to do right now, is look at that situation when you have to make a little bit of an adjustment here. So let's look at example number 2. Example number 2 has x plus 2y equals 4, and it also has x minus y equals negative 5. Now when we add these, what do we get? We get a 2x. We add these, we have 2y minus y gives us 1y, and then when we add these, we get a negative 1. Now look what happened here. We just changed from 2 equations to 1 equation, but we still have 2 variables, which means it's impossible to solve that way. Okay, so let's go back and revisit this thing and see if there's anything else we can do about it. Alright, so let me rewrite this. X plus 2y equals 4, and x minus y equals negative 5. Alright, so we still want to add these two, but we have to make a couple changes here. So, and you can do either one. We have to, this is called the elimination method, 4.2, that's the name of the section. We have to either eliminate the x's, so that when we get our answer here, it just has a y equals something, or we have to eliminate the y's so that it is just x equals something. Doesn't matter which one you get rid of. You usually try to get rid of the simplest one. In this case, since there's no number in front of this x or no number in front of this x, we will eliminate the x's because it's the simplest one. This has a 2 in front of it, and this doesn't have anything in front of it. And again, it doesn't matter which one you eliminate, but eliminating the x, because it's the simplest, seems to be the easiest. Alright, so what keeps me from adding these and getting 0? Well, they're both positive. If one was a positive and one was a negative, when we added them, they would cancel out, right? And what do we know about negative signs? That we can put a negative sign here as long as we change the signs of everything else in the equation. Okay, so I just did that. Now when I add those, I get 0. When I add those, I get 3y. And when I add these, I get 9. Divide by 3, and y equals 3. Alright, so I just found out y equals 3. Now let's take our original problem. It doesn't matter which one, but let's take this one. X plus 6 equals 4. Subtract 6, and we get x equals negative 2. So when y is 3, x is negative 2, or you write your answer with the x first, and then the 3, and then the y value. This is where these two equations, if we were to graph them, would cross each other. These two numbers, the negative 2 and the 3, the x and the y, if we put it in here, it would be a true statement. If we put it in here, it would also be a true statement, and that's what we're looking for. Alright, so if you're not getting two numbers that add up, give you 0, then you do some finagling in order to make that work. And in this particular one, all we did is change the signs of everything in the equation so that these would cancel. Let's try one where we have to do a little bit more, and we'll do that in the next video.